In this video, I'm going to do a quick review of linear functions and do an example where we put all this together and graph a line. So what is a linear function? So a linear function is an equation that's written like this right here. So f of x equals ax plus b, or commonly known as y equals mx plus b. So remember, f of x can be written as y can be written as f of x. So those are just two different options to represent the same thing. And if you look at what comes after, you've got a number in front of x. So you have an x variable and possibly a number that's added or subtracted to the end. Notice there aren't any x squareds or x to the q or third power or any x's to, greater or power. So when we graph these equations or functions, these graphs always make a straight line. And so line is a part of the word linear. So linear equations, linear functions are always graphed and make a straight line. And so let's take a look at this equation. So I'm going to give you an example. So let's say I have the equation y equals 3x plus 4, or f of x equals 3x plus 4. You could write it either way. And so this is a linear equation, and there's two numbers here. So we've got a number in front of x. The number in front of x, that's always the slope. And the number that's by itself, not with the x, that's always the y-intercept. Now keep in mind this could be written differently, so I could write it y equals 4 plus 3x. So even if it's written like this, the 3 is still the slope, so it doesn't change what the slope is and what the y-intercept is. So slope is always the number in front of x, y-intercept is always the other number. And so what do these mean? Well, the slope always represents the change of y per unit x. So for example, I'll just make up an example here. Let's say we're taking a taxi. This equation could represent, me having to pay $4 just as an initial fee when I get into the car. And then 3x represents, so 3 would be my rate of pay, so maybe I have to pay $3 per minute after the taxi starts driving. And so $3 per minute is my rate per 1 minute, and then my y-intercept 4 is sort of that initial fee that I have to pay. And so there is a note here how to find the y-intercept in case it's not obvious in the equation. So sometimes equations are not solved for y and not in this form. So if you want to find from an equation, you can always plug in 0 and find y to get the y-intercept. So that's a helpful hint. And sometimes, that's this note here, we also talk about the x-intercept of a function, especially if maybe it's a story problem and we're interested in that. And so that's the location on the graph where the function crosses the x-axis. And if you have an equation, all you have to do is plug in 0 for y and then solve for x if you want the x-intercept. So the intercepts, x and y intercepts, are pretty easy to find when you have an equation, which is nice. And so then this last part here, here's two suggestions of how to graph. So they're two different suggestions. You can kind of pick which one you like the best, and I'll show you how these work in a minute when we do an example. But the first suggestion is just to pick 3 or 4 numbers, any numbers, okay, and you plug them in for x to find y. We can organize this in a table of values, and then we plot those ordered pairs and we connect them. Now really, you only need 2 points minimum to connect to make a line. This is suggesting 3 or 4 is a good idea because, if let's say you only pick 2 and you made a mistake on one of them, you wouldn't really know because it'd make a line. Whereas with 3 or 4 points, I've seen this before where, maybe I'm plugging them in and I get some points and they all line up to make this line, and then my other point is like off to the side. So it makes it so when I connect them, it's not a line. That tells me that I made a mistake and I need to start over and do that again. And then the other option is just use the y-intercept and the slope to plot the second point. And I'll go over that next. Okay, so we're going to look at this example, f of x equals 4x minus 2, and we're going to answer all of these questions with the goal of just graphing this. So the first question asks, what is the slope? So if we look at the equation, it's always the number in front of x, so that's going to be 4. In this case, it's going to be the slope. And then the y-intercept is always the number that's by itself, not with the x, and that's going to be negative 2. You have to be really careful here. If there's a subtraction sign, that subtraction sign comes along with that number, and that's part of that y-intercept. So the y-intercept is negative 2. Now this question asks, though, for the ordered pair. So if we look at the graph, here's the y-axis. If we plot the point at -2 on the y-axis. And we think about, well, what is that ordered pair? Well, that ordered pair is 0, -2. So we'll just write 0, -2. So now to graph the equation, what we're going to do is we're going to pick some values for x, and they're picked here for us in this table. We've got -1, 0, 1, and 2. We're going to plug them into the equation for x and find y, and then we're going to plot those coordinate values, or those coordinate pairs. So for the first one, -1, I'm going to write down the function. So the function, if I want to find f of -1, we're going to do 4 times -1 minus 2. So that gives us -4 minus 2, which is -6. So that, as an ordered pair, is -1, -6. So if I plot that, it would be about right there. Okay, I'm going to do the same thing for the next one. So I'm going to plug in 0 for x. So 4 times 0 is 0, minus 2 is -2. And so 0, -2, we already have that point. That's the y-intercept. The next one, x equals 1. I'm going to plug in 1 for x. So 4 times 1 is 4, minus 2 is 2. So the point 1, 2. So over 1, up 2 would be right there. And then last point, we're going to plug in x equals 2. So 4 times 2 is 8, minus 2 is 6. So that gives us the point 2, 6. Now, are these the only points on the line? No, there are infinitely many points on the line. These are the points that I got because of picking the values -1, 0, 1, and 2 for x. You could certainly pick different numbers for x and get the same line. So they should all connect to make a line, and in this case, they do. And again, like I said before, if you ever plot them and one's, kind of off to the side, not lined up with everything else, then you should probably go back and redo that one point to see if you made a mistake. And so here we have a graph of our function. I also want to mention the other method of graphing real quick in case that's something that you're interested in. So the other method of graphing says, step 1, plot the y-intercept. So go on the axis, and I'll do it in green so you can kind of see how I'm doing it the second way. So we go up to the y-axis and we plot a point at -2. And then we look at our slope of 4, and we write it as a fraction. So we can always put a number over 1 to make it a fraction if it's not a fraction, if it doesn't look like a fraction the way it's written in an equation. And then we can think of the top number as our rise. So how far up or down do we need to go? If it's positive, it means go up. If it's negative, it means go down. So this rise means to go up 4 is what that's telling us. And then the bottom number is run. So we think of rise over run. Run is our left and right, or horizontal movement. So if it's positive, we go to the right. If it's negative, we go to the left. So +1 means to go right 4. So it's basically, the slope is giving us directions. It's saying, hey, start at the y-intercept of -2 and then go up 4 to the right. Sorry, I wrote 4. I should have said 1 there. Let me rewrite that. So go up 4 and right 1. And so I'm going to start at the y-intercept and I'm going to go up 4. So 1, 2, 3, 4, and right 1. And hey, I'm right at the point that I already have, which is great. So then up 4, right 1. Up 4, right 1. And so I keep, and I could keep going, if I wanted to, but that's enough to graph the line. So that's another good method. If you like that method, then you can just use that one. And then the last part, use the equation to find the x-intercept, then plot that point on the graph below. Now we can kind of, we could probably estimate, like just eyeballing it there, it looks like it's maybe between 0 and 1, but these tick marks are so small that it's really hard to see. So the nice thing about the equation is we can find an exact x-intercept if our eyes just can't find it exactly. So all we have to do is take our equation and we're going to plug 0 in for y and solve for x. Because at the x-intercept, the y is 0. You're not going up or down. You're staying at the x-axis. So I'm going to write, instead of f of x, I'm going to write a 0. Okay, then I'm going to write the rest of the equation, 4x minus 2. And then I'm just going to solve. So I'm going to add 2 to both sides. So 2 equals 4x. I'm going to divide both sides by, not 2, I'm going to divide both sides by, let me just erase that real quick. Divide both sides by 4 because we want to solve for x. So we're getting rid of that 4 in front of the x. So 2 divided by 4 is 1/2. We can write it 1/2 as a fraction or 0.5 as a decimal, either one. And so the y-intercept here, or the x-intercept at 0.5 or 1/2. And, you know, it looks like it's about 1/2. It looks like it's between 0 and 1, but it's nice to have that confirmation from the equation since it's, you know, a little bit hard to see from the graph.